In 1519, Spanish soldiers marched into the Valley of Mexico, expecting a primitive lakeside settlement. What they found was a city of 200,000 people, fed almost entirely by thousands of artificial islands built across the surface of Lake Texcoco. But within 50 years, the Spanish had drained the lakes, filled the canals, and buried a 700-year-old farming system beneath colonial streets and cattle ranches. So what exactly were the Chinampas? How did they work? And why did the people who marveled at them tear them apart? To understand the Chinampas, you have to start with the geography that made them necessary. The Valley of Mexico sits at roughly 7,300 feet above sea level, ringed by volcanic mountains on nearly every side. At the time the Aztecs arrived, the valley floor held 5 interconnected lakes. Lake Texcoco was the largest, and its water was brackish, meaning slightly salty. The freshwater lakes of Xochimilco and Chalco lay to the south, fed by mountain springs, and these would become the heart of the Chinampa system. The Mexica people, the group we now call the Aztecs, did not originally control this valley. They arrived in the 1200s as semi-nomadic outsiders, pushed from place to place by more established groups who had already claimed the best agricultural land around the lake shores. The Tepanecs, the Acolua, and other settled peoples viewed the Mexica as rough newcomers, useful as mercenaries, but not worthy of prime territory. According to their own origin stories, the Mexica were guided by a prophecy to settle where they saw an eagle perched on a cactus eating a serpent. That image, still on the Mexican flag today, supposedly appeared on a small marshy island in the western part of Lake Texcoco around the year 1325. It was a beautiful prophecy, but the island it led them to came with a nearly impossible problem. So the Mexica founded their capital, Tenochtitlan, on an island in the middle of a lake around the year 1325. It was a defensible position, surrounded by water on every side, with clear sightlines in all directions. But it came with an enormous problem. There was almost no dry farmland. The island was small, the lakebed was shallow and muddy, and the surrounding water was too salty for irrigation. If the Mexica wanted to grow into a major power, they needed to solve a food crisis that no other civilization in the valley had faced quite this way. The solution they developed, possibly borrowing from earlier techniques used by other lake-dwelling communities, was the Chinampa. The word comes from Nahuatl, the Aztec language, and it roughly translates to square made of flowers, though the reality was far more engineered than that name suggests. Building a Chinampa started with the lake bed itself. Farmers would mark out a rectangular plot in the shallow water, typically about 30 meters long and 2.5 meters wide, though sizes varied. They drove wooden stakes into the mud to create a boundary, then wove reeds and branches between the stakes to form a kind of underwater fence. Inside this frame, they layered lake sediment, decaying vegetation, and soil, building the surface up above the waterline. On top went rich organic matter, composted plants, and more mud dredged from the canals. If you have ever built a lasagna-style raised bed in your own garden, you already understand the basic principle, but the Aztecs were doing it on open water, at industrial scale, with no power tools. The layering process was not random. Builders alternated between dense, heavy materials like lake mud and lighter organic layers of reeds, cornstalks, and aquatic vegetation. This created a structure that was both heavy enough to stay in place and porous enough to let water wick upward through the soil by capillary action. The roots of growing plants would eventually reach the water table just beneath the surface, meaning that once established, a Chinampa was essentially self-irrigating. The finishing touch was critical. Farmers planted willow trees called ahuejotes along the edges of each Chinampa. These fast-growing trees sent their roots deep into the lakebed, anchoring the entire structure in place. Over time, the roots wove together beneath the surface, locking neighboring Chinampas into a permanent interconnected grid. The willows also served as windbreaks, protecting tender crops from the gusts that swept across the open lake surface. The chinampas were not truly floating. They were rooted to the bottom of the lake, with water flowing through narrow canals between each plot. A completed chinampa, well maintained, could last for generations without needing to be rebuilt. But the construction was only the foundation. What made the chinampas truly extraordinary was what happened in the water between them. Those canals were not just pathways for canoes. They were the circulatory system of the entire farm. Farmers would dredge nutrient-rich mud from the canal bottoms and spread it on top of their plots as fertilizer. The water itself carried dissolved nutrients from decomposing organic matter, essentially feeding the roots of every plant from below, while the sun fed them from above. The chinampas operated as a closed-loop nutrient cycle, where almost nothing was wasted and almost nothing had to be imported. European farms in the 1400s relied on a fallow rotation system, leaving a third or more of their fields unplanted each year so the soil could recover its fertility. Chinampa farmers never had to do this. The constant supply of fresh nutrients from the canal system meant the soil renewed itself continuously. Some researchers estimate that a well-maintained chinampa could produce up to 7 harvests per year. That is not a typo. 7. But raw productivity was only half the story. What chinampa farmers grew on those plots was just as remarkable as how often they harvested. Maize was the staple, grown alongside beans and squash in the traditional Mesoamerican polyculture known as the Three Sisters, where each plant supports the others. Bean roots fix nitrogen in the soil, squash leaves shade the ground to retain moisture and suppress weeds, and maize stalks provide a climbing structure for the bean vines. This is not folk wisdom. Modern soil scientists have confirmed that the Three Sisters system measurably improves yields and soil health compared to planting any of the 3 crops alone. On top of this foundation, chinampa farmers grew tomatoes, chili peppers, amaranth, chia, herbs, medicinal plants, and enormous quantities of flowers. The flower trade was a major part of Aztec culture and economy, woven into religious ceremonies, market exchanges, and daily life. Chinampas supplied much of it, and some plots were dedicated entirely to marigolds, dahlias, and other ornamental species that held spiritual significance. The idea that a functioning farm would devote prime growing space to flowers tells you something important about how the Aztecs understood agriculture. It was never purely transactional. Beauty was considered part of the system's purpose, and the precision did not stop at what they planted. Chinampa farmers controlled when and how every seed went into the ground. Seedlings were often started in floating seed beds, small rafts of compressed mud and vegetation where seeds could germinate in warm, protected conditions before being transplanted onto the main plots. This technique, which the Aztecs called chinamitl, was essentially an early version of the plug tray systems modern nurseries use today. It extended the growing season and allowed farmers to stagger their plantings with remarkable precision. While one section of a chinampa was being harvested, another section was already mid-growth, and a third was being freshly planted. Picture a farmer in a flat-bottomed canoe, poling between rows of maize on one side and freshly transplanted tomato seedlings on the other. That level of staggered production was happening across thousands of plots simultaneously. But the chinampas were not just gardens. They were entire ecosystems. The canals between the plots teemed with fish, frogs, and axolotls, the large aquatic salamanders native to the lake system. These animals consumed insect larvae, algae, and aquatic weeds, acting as a natural pest control system that required no human intervention beyond keeping the water clean and the canals connected. Birds nesting in the willow trees ate caterpillars and beetles that might otherwise damage crops. Dragonflies patrolled the canal surfaces, catching mosquitoes on the wing. The entire Chinampa zone functioned as an integrated ecosystem where agriculture and wildlife supported each other rather than competing. This was not a romantic accident. It was deliberate management. Aztec farmers understood that the fish kept the canals healthy, that the canals kept the soil fertile, and that the soil kept the crops productive. Disrupting any part of the chain would weaken the whole system. When modern ecologists describe this kind of mutually reinforcing biological network, they call it an agroecosystem. The Aztecs simply called it farming. However, none of this would have worked without solving a problem that threatened the entire system from the beginning. Salt. Water management across the lake system required engineering on an enormous scale. The Aztecs built a massive dike, attributed to the ruler Nezahualcoyotl, that stretched more than 10 miles across Lake Texcoco. This dike separated the salty water of the eastern lake from the fresher water of the western section near Tenochtitlan, protecting the Chinampas from salt intrusion. The structure was wide enough for several people to walk abreast on its crest, and it included sluice gates that could be opened or closed to regulate water levels on either side. Aqueducts carried fresh spring water from the mainland hills into the city, some of them running along the tops of the causeways that connected Tenochtitlan to the shore. The most famous of these aqueducts brought water from the springs at Chapultepec, several miles away. Within the Chinampa zone itself, smaller channels and gates controlled flow between individual canal rows, preventing both drought and flooding on the farm plots. The entire system required constant, coordinated maintenance by thousands of people, and it functioned reliably for centuries. The result of all this engineering was staggering in scale. At its peak, the Chinampa system covered an estimated 9,000 hectares across the southern lakes. That is roughly 22,000 acres of intensively farmed land, all of it built by hand on what had been open water. This agricultural base supported Tenochtitlan as the largest city in the Western Hemisphere, and one of the largest in the entire world at the time. Estimates vary, but the population likely sat somewhere between 200,000 and 300,000 people. For comparison, London in 1500 had about 50,000 residents. Paris had around 200,000. Tenochtitlan was competing with the biggest cities on Earth, and it was feeding itself from a lake. That was the world the Spanish walked into. The accounts they left behind make clear they understood they were looking at something extraordinary. Bernal Díaz del Castillo, a soldier who later wrote one of the most detailed first-hand accounts of the conquest, described approaching the city across one of the long causeways that connected Tenochtitlan to the mainland. He wrote about seeing towns and temples rising from the water, canoes moving in every direction, and gardens growing on the lake itself. He compared the scene to the enchanted visions in a popular romance novel of the time, Amadís de Gaula, because it seemed too extraordinary to be real. Some of his fellow soldiers asked aloud whether they were dreaming. The causeways themselves were engineering marvels, wide enough for 8 horsemen to ride abreast, with drawbridges at intervals that could be raised to defend the city. Along the edges of the causeways, Chinampas extended in neat rows as far as the eye could see, and the air smelled of flowers and wood smoke and cooking maize. But nothing prepared the Spanish for what they found at the market. The market at Tlatelolco, Tenochtitlan's sister city on a neighboring island, left them stunned. Diaz described tens of thousands of people buying and selling goods on a single day, including enormous quantities of fresh produce that had been canoed in from the surrounding Chinampas that same morning. He cataloged the variety with obvious fascination: fruits, vegetables, honey, cooked food, pottery, cloth, obsidian blades, live animals, dyes, and medicinal herbs. Cortés himself, in his letters to King Charles V of Spain, noted that the market was larger and better organized than anything he had seen in Seville or any other Spanish city. If you are learning something from this video, take a second to subscribe. I cover stories like this every week, where forgotten history meets the science of how things actually grow. Now, here is where the story turns. The Spanish did not arrive as students of Aztec agriculture. They arrived as conquerors, and the campaign that followed was devastating on every level. After a prolonged siege in 1521 that involved cutting off the aqueducts, blockading the causeways, and launching attacks from brigantines built on the lake itself, Cortés and his indigenous allies captured Tenochtitlan. The city was heavily damaged in the fighting. Tens of thousands of its residents were dead from combat, starvation, and the smallpox epidemic that had swept through the valley in the months before the final assault. Cortés ordered the old city razed and a new colonial capital, Mexico City, built directly on top of it. What followed over the next several decades was the slow, deliberate destruction of the Chinampa system and the lake itself. The Spanish brought European agricultural practices centered on livestock grazing and grain monoculture. Cattle, sheep, and pigs required dry land. Wheat needed fields, not canal plots. The logic of colonial agriculture left no room for the Chinampa model, so the Spanish began draining the lakes. At first, the motivation was practical. Tenochtitlan had always been vulnerable to flooding, and the Spanish, who had built their new city using European construction methods not designed for a lake bed, suffered repeated catastrophic floods. The flood of 1629 was so severe that Mexico City was partially submerged for 5 years. Colonial engineers responded by digging drainage canals and tunnels to divert water out of the valley entirely. Flooding was only part of the reason. The colonial government also wanted to impose European-style land ownership, where individuals held title to defined parcels of dry ground. The communal, water-based farming system of the Chinampas did not fit into Spanish legal frameworks. Indigenous farmers were pushed off their plots, canal networks were neglected, and the intricate water management systems that had kept the Chinampa zone functional for centuries fell into disrepair. There was also a cultural dimension to the destruction. The Chinampas were deeply tied to Aztec religious life, seasonal ceremonies, and community governance. Dismantling the farming system was, in practical terms, also a way of dismantling the social structures that had organized Aztec society. Colonial authorities replaced indigenous crop rotations with European grains, introduced livestock that trampled and polluted the remaining canal systems, and redirected labor toward mines and colonial estates. By the 1700s, most of the original lake system was gone. What had been a vast network of interconnected waterways was becoming dry valley floor. The draining continued through the 1800s and into the 1900s, and today almost nothing remains of the original 5 lakes. Mexico City, one of the largest metropolitan areas on Earth with over 21 million people, sits on the dried lake bed. The city sinks several inches each year because the old clay lake bed compresses as groundwater is pumped out from below. Buildings tilt, pipes crack. The Metropolitan Cathedral in the city center leans noticeably to one side. The flooding problems that the Spanish tried to solve by draining the lake have been replaced by water scarcity problems caused by the same decision. A city built on a drained lake bed, running out of water. But not everything was lost. In the far southern reaches of what was once Lake Xochimilco, a small network of Chinampas survived. Farmers in the Xochimilco district continued working their canal plots through the colonial period, through Mexican independence, through revolution, and into the modern era. Today, roughly 2,500 acres of active Chinampas still exist in Xochimilco, threaded through by canals that are now fed by treated wastewater and spring-fed channels rather than the original lake. In 1987, UNESCO designated the Chinampa zone of Xochimilco as a World Heritage Site, recognizing it as one of the last living examples of pre-Hispanic agriculture in the Americas. The colorful trajineras, the flat-bottomed boats that tourists ride through the canals on weekends, float past working farms where families still grow lettuce, spinach, herbs, coriander, radishes, and flowers using methods that trace directly back to the original Chinampa builders. Some of these families have worked the same canal plots for 5 or 6 generations. They still dredge mud from the canal bottom to fertilize their beds. They still start seedlings in compressed blocks of organic matter called chapines, a technique that predates European contact. And they still harvest by hand, loading produce onto flat boats and poling it through the canals to the collection points where trucks wait to carry it to markets across Mexico City. On a busy morning in Xochimilco, you can watch a farmer standing knee-deep in a canal, scooping dark mud onto a chinampa bed that his grandfather built, while apartment towers rise in the haze less than a mile away. But survival and thriving are not the same thing. The farmers of Xochimilco face constant pressure. Urban sprawl from Mexico City pushes into the canal zone. Water quality in the canals has declined, and invasive species like tilapia and water hyacinth have disrupted the original ecosystem. The axolotl, once abundant throughout the lake system, is now critically endangered in the wild, surviving almost exclusively in the Xochimilco canals. Despite all of this, the chinampas keep producing. And in recent years, researchers and agricultural scientists have started paying serious attention to what this system can teach modern farming. The International Institute for Environment and Development published studies showing that chinampa-style raised bed systems in tropical and subtropical climates can match or exceed the per-acre productivity of conventional agriculture, with zero synthetic fertilizer and drastically lower water consumption. Experimental chinampa projects have appeared in places as far from Mexico as Bangladesh, where floating gardens on monsoon floodplains use a strikingly similar construction method, layering water hyacinth and decomposing vegetation into raised beds that rise above seasonal floods. In parts of Myanmar, lake farmers grow tomatoes on floating plots in Inle Lake, using techniques that echo chinampa principles without any historical connection to Mesoamerica. From the monsoon plains of South Asia to the highland lakes of Southeast Asia, the same idea keeps appearing wherever people need to grow food on water. But the most important work is happening back where it all started. Researchers at the National Autonomous University of Mexico have been working with Xochimilco farmers to restore degraded chinampas and document traditional techniques before the last generation of experienced chinampa builders retires. The effort involves clearing invasive water hyacinth from clogged canals, rebuilding eroded chinampa edges with traditional willow plantings, and reintroducing native species like the axolotl into cleaned waterways. Some of the restored plots have returned to full production within 2 growing seasons, suggesting that the system is remarkably resilient when given the chance to recover. If you listed the core principles of the chinampa system, you would end up describing almost exactly what modern, sustainable agriculture is trying to achieve. The waste from one part of the system feeds another, so nutrients cycle continuously instead of draining away. Diverse crops grow together and support each other, the way the three sisters do, instead of competing in monoculture rows. Biodiversity handles pest control instead of chemical sprays. The soil never needs to rest because it never gets depleted, and all of it runs on sunlight, water, and organic matter, with nothing synthetic required. Industrial agriculture feeds the modern world, and it would be dishonest to pretend that chinampas could simply replace it at global scale. The system was designed for a specific geography, a specific climate, and a specific set of crops. But the underlying engineering principles are not locked to one place or one century. The idea that you can build soil fertility from water, organic matter, and careful design, rather than from a bag of synthetic fertilizer, is as relevant now as it was in 1400. Backyard gardeners who build raised beds, fill them with compost, and irrigate from a rain barrel are practicing a simplified version of the same logic that drove the chinampa system. The difference is that the Aztecs did it across 22,000 acres, feeding 250,000 people for 7 centuries straight. What the Spanish destroyed in the Valley of Mexico was not just a collection of garden plots. It was a working proof of concept that a major civilization could feed itself sustainably, intensively, and beautifully, all from the surface of a lake. The Chinampas lasted 700 years before anyone decided to tear them apart. Industrial agriculture, by comparison, has not yet survived a single century without serious ecological consequences. The farms in Xochimilco are still there. The canals still flow, and the ahuejote willows still line the edges of Chinampa plots, their roots reaching down into the same mud that Aztec farmers shaped by hand 6 centuries ago. If stories like this one change how you think about what a garden can be, the video on screen right now goes even deeper into another lost growing system that modern science is only starting to understand. I'll see you there.